In the first question, we are given the following graph and want to represent it as an adjacency matrix and then as an adjacency list. So let's first go over what those are. An adjacency matrix is a 2D array with each index representing a single node. The row index represents the start node, while the column index represents the end node. If there is an edge between them, the entry for those indices for the matrix is marked as 1, otherwise 0. So for our very simple graph on the right, we have an edge from 0 to 1, 1 to 2, and 0 to 2. So for those indices, the matrix's entries are 1. An adjacency list is an array of array lists. If there is an edge from vertex x to vertex y, then the array list at index x will have a y in it. So going back to our graph, it has edges from A to B, A to D, B to C, C to F, D to F, D to B, D to E, E to F, and G to F. So the adjacency matrix looks like this. The entries at indices A and B have a 1, the entry at indices A and D have a 1, and so on. And this is the adjacency list. Since there are 2 vertices pointed to by A, the list at index A has B and D. B only points to C, so C is the only vertex in the array list at that index, and the rest is the same idea. And the last thing we want to consider is when this graph is undirected. So in that case, for each directed edge in the original graph, there will be an additional one added to the representations in the opposing direction. So this is what the adjacency matrix and list look like, and you can see that things look more symmetric as opposed to the directed representations.